Okay, so let's get started. I've pushed a couple commits to my repository, and so this is what my repository looks like now. My hope is that you have all forked it, and I know you haven't because it says 49 forks and there's like 65 enrolled. So that means there's like 16 of you who have not yet forked my repository. So uh, be sure you watch Wednesday's lecture, which gives you instructions on how to fork the repository and set the upstream repository so that you can pull all of the course content to your thing. Okay. And if you need any help getting that set up, come to me during office hours. I'm happy to get you set up. A lot of this stuff is like a one-time setup, and then pulling the content, that's going to be like every lecture. But let me just show you how to pull your content, okay? So navigate in your terminal to the class repository, wherever you have that. So it might be on your desktop, it might be in your home directory, wherever it might be. Mine is just in my home directory, and I'm gonna, it's 25-fall stats 21, so I'm gonna just cd to change directory. I can just start typing 25, and this is the only directory that starts with 25, so I hit tab and it auto completes. And so now I'm located inside the class repository. And just to kind of check, I can type ls to see what's in there. And so far I have up through 1-2 and the upstream commit, but I've added additional files. I, the professor, have added additional files. And so as the student, I would need to pull the new files. So what I'm going to do is I'm going to just type in git pull, and I want to pull from the upstream repository. So I'm going to type in git pull upstream, and on the upstream repository, I want to pull from the main branch. So it's going to be git pull upstream main, and you hit that, and that should, assuming you have your upstream repository set up, it's going to go to GitHub, download that stuff. So it says a fetch, it's fetching the stuff, and then it's merging that commit to your, I guess, your timeline. Okay. And so now, and we can see it's added 3 files, 1-3, which is going to be today's lecture, along with 2 scripts that actually go along with Wednesday's lecture. So I was informed today that you guys have had no discussion sections. So I'll get in touch and try to figure out what's going on with the TA. I know there was in the beginning the TA that was first hired. Something came up and they could no longer do it, and so we hired a different TA, and I think something during that switch got messed up, and nobody has shown up to anywhere. So I will reach out, make sure you will have discussion sections next week. What's supposed to happen in discussion sections is basically, I have these lectures, and I'm not always able to cover every single thing in all of the lectures. So when we get through a lecture or whatever I don't cover, I kind of expect you guys to just kind of read a little bit on your own. And so as you have questions about any of that lecture material or that content, the TA is a resource where you can kind of go and follow up and find out that stuff. Okay. But anyway, yeah. So in lecture 1-2, there are a couple scripts associated with it. Really, really, really basic scripts. Like if you open up script 1, it's just print hello world, okay? But it's just an example of how you can, if you have a Python script, okay, Python scripts end with a .py extension, you can call external scripts from inside a Python notebook, okay? And that's what that is. And then script 02 is also a very simple thing where it's going to say hello and along with a variable name, okay? And that gets pulled up in there, okay? So you can test all of that out, just on your own time, looking at 1-2, okay? So anyway, that's git pull upstream main. So if you have your upstream repository, this should work and it should download the 3 files. If you check ls, now you should see lecture 1-3 along with scripts 1 and 2. And then if you want to push that to your own repository on GitHub, because if we go to GitHub, let me go to the student account. So GitHub Miles Chen-student, and I check this one. This one doesn't have 1-3 yet, or the scripts. And if you want to push that, you just type in git push. Okay, and git push will pull to your own repository. And if I refresh, it should now appear there. Okay, and so now we have that, the scripts and 1-3. Okay, and again, if you're having trouble getting any of this executed or set up, come to office hours. And I can help you. You can go to your TA and they can help you as well. All right, so anyway, I'm gonna open up the notebook for 1-3 and we'll work through this, okay? Regarding your homework, this is what you need to do is you have a notebook and you'll need to export it to a PDF. And so probably the simplest is to, so if you're using VS Code, you can do export, and you can try exporting to PDF, but I keep running into errors because with my tech installation, I'm like missing a package, but then the package isn't available in the repository. So anyway, you can just export to HTML, okay? And I'm going to click export here, and it should do it. Okay. Yeah, would you like to open the exported file? You can click yes, or it's now here. And then from here, you'll just print to PDF, okay? And that will be the simplest way. It's really important that you do not just upload the HTML directly to Gradescope, because if you do that, it just shows up as one really, really, really long page that's like too tiny for anybody to read. The grader is not going to be able to read your stuff, or the TA. So make sure you print so it's on different pages. And so this document is what, like 12 pages long or something. And then save it as a PDF. And then on Gradescope, you can tag each page with and say this page corresponds to page number 2 or 3. Yeah. The export. So okay, on VS Code, all the way to the right, there's like a triple dots menu, and then there's an export on VS Code. If you are using Jupyter, okay, so let me so if you're using like Jupyter Lab, let me just launch Jupyter Lab. Takes a couple minutes, couple seconds to get running here. But in Jupyter Lab, in the menus, there is a download as, I believe. Okay, so here's Jupyter. All right, so let me go ahead and open up lecture 1-3. So here it is here. And then over in the menu, I'm going to do File. And we're going to do, Save. I have to click Trust. Oh, this is the HTML, sorry. Okay, so we're going to do File, Save and Export Notebook as HTML in the File menu on Jupyter. So the other option, you go to File, Save and Export HTML, and that should produce it right here, and then print to PDF. Okay, does that make sense as far as how you're going to go from your IPython notebook? Let me see. I think right now, if I try to download as a save and export as PDF, it'll try to knit, but I think something, I'm missing some tech packages right now. Yeah, you get all kinds of stuff. All right, so it says this math R SFS. So this is there's all of this gibberish. So the thing with error messages is the error message, once you're able to read it, like it will often tell you how to fix it, like what's wrong and how to fix it. A lot of times when you get an error message, you're like, I don't know what to do. But a lot of times if you read it and you're able to understand, so in this case, the key here is that it's missing this. This is a LaTeX package. And so this is how you would fix it. But then for whatever reason, when I was trying to download this package, is like that package isn't available on the LaTeX tech servers. TechLive is the service, and so I don't know how to fix it if I can't download the package. Right? It's kind of like you need this package, but I don't have the package. So anyway, that's how you're going to do your homework: is you open the Python notebook, work all of your stuff. Oh, the other thing regarding your homework, make sure you look at the output and make sure the requested output is visible, okay? Because the TA doesn't have time to open up your notebook and like run the code itself, okay? So, if the code asks a question and you need to provide an answer, make sure that answer is visible in the thing, because they're just reading a PDF. They're not going to like copy and paste your code and execute it to make sure you wrote the code correctly. They're just going to look at the output. And if the output is correct, then you'll get the points. And if the output is wrong, or if the output's missing, you're not going to get the points. So make sure the output is visible. And it could be as simple as just printing the results or calling the function. But make sure you do that. Okay. So I'm gonna exit Jupyter, and we'll run it on in VS Code. Okay, all right, I'm gonna go ahead and clear all of my outputs and we'll work through this. Okay, so this is just kind of an introduction to Python stuff. Can you guys see that all right? Okay, so regarding Python, we'll just start off with the very basics, basic data types and variables. Again, all of you have taken Stats 20, at least that's the prerequisite for this class. So you guys are already familiar with data types and stuff in R. And the transition from R to Python, in my opinion, is actually pretty smooth and easy, okay? As far as the way Python handles things, it takes care of a lot of stuff behind the scenes for you, so you don't have to worry about it. For example, but whereas like if you switch over to say Java or C++, then you have to suddenly start worrying about memory management and things like that. You have to declare basically these buckets where that are going to hold things. But both Python and R are what we call dynamically typed. So if you have a variable and you say, hey, I want you to store an integer, it'll be like, all right, X is an integer. And then later on you want to say X is, I'm going to put in a decimal value, right? We're going to take the number, divide, 3 divided by 2, and now you have a 1.5, okay, 1.5. And you say, store that to X, that's going to work just fine. Whereas in something like C++, you declare these buckets that are like, this thing is going to hold integers only. And if you ever try to put, I don't know if you guys took Pic10a or the C++ class, and if you ever try to put like a decimal value inside that thing, problems, right? Or it doesn't behave the way you might expect. So anyway, Python and R both dynamically typed, a bunch of stuff that are similar. The object-oriented stuff in Python is very different from object-oriented stuff in R. That's probably the biggest difference. The other biggest difference is Python starts counting at 0 and R starts counting at 1, but that's like a superficial difference. But it's like something, it's like the hardest thing for your brain to adapt to. But anyway, we'll talk about just some of the basic data types in Python. Okay, so these are the basic types of data that exist in base Python. There are going to be other data types that we will use, like arrays and data frames, but those are not part of base Python. We have to load up packages like NumPy and Pandas in order to handle those other things. But as far as like base types, the ones that we're going to commonly interact with, you got strings, integers, floats, booleans. Booleans are true, false, like the logical values in R. and things like that. And then you also have none, and none is what Python R calls it null, Python calls it none, okay? And then we also have other really kind of important things. We got lists and things that are closely related to that, tuples and ranges, sequences of iterables. And then we have this mapping thing called a dictionary, which is really nice. Okay, and then there's also sets and bytes, but and things like that. Okay, so anyway, what is the type of something? You just use the function type, you put the object inside the thing, and Python tells you what it is. So what is the type of quote to quote? That's going to be a string, right? Because it's enclosed in quotes. All right. What about the number 2 by itself? That's an integer. Okay. And then if it's a float, if you have a decimal 2.0, that's a float. Okay. True is a Boolean, and then none is none type. Okay. All right, we got some basic math operations. I don't think there's any kind of surprises here. The biggest surprise here is that certain functions that you would expect exist in Python aren't part of the base set, and you have to load a library in order to use them. So you have like, addition, multiplication, subtraction, division, and modulo arithmetic and powers. And so you can do something like, all right, so here I'm going to take the integer 10 and the integer 5, right? And then I can just say, hey, what is the type of each of these things? These are integers. I can do x plus y and assign that to z. Z is going to be the integer 15, okay? So what's the type on z? That's an integer. Z is 15, okay? If you multiply integers, you get back an integer. So x times y is going to be 50, and that's an integer 50. Okay, but if you do division, the result is always going to be a float. So 10 divided by a 5, we'll go, hey, what's that? That's the number 2, but it's always going to be a float. So even if it's 10 divided by 5 is a whole number 2, it's not going to be the integer 2. It's always going to be a float 2. And Python is very explicit. If it's the floating point 2, you will always see a decimal, okay, a decimal point. So you'll either see a 2.0 or a 2 point to distinguish a float from an integer. So that's a nice thing that R doesn't do. Like when you see the number 2 in R, you don't know if it's an integer or I guess, type double. But Python's always kind of very explicit. Okay. If one of your numbers is a float, like 10.0, and you do addition or multiplication, the results of those things will be floats. So 10.0 plus 5 is going to be 15.0 a float. 10.0 times 5 is 50.0. Okay. Did you guys talk about, are you guys familiar with like the limits of floating point numbers? So in, so in, I talk about this in my 102A class, and somewhere along the way, somebody should tell you that you cannot treat floating point numbers like real numbers, okay? So for example, if you do 0.1 plus 0.2 on a computer, the answer is not equal to 0.3. It looks like 0.3, but it's not equal to 0.3, okay? Yeah, it's like 0.30000, a whole bunch of zeros and like a tiny little 4 or something. And it's the same problem that if you ever played with like an old calculator and you do something like 10 divided by 3, on the calculator you get 3.33333, okay? And if you take that number and you multiply it by 3, you don't get back 10, you get 9.99999, okay? And so there is a difference, right? So in real numbers, 10 divided by 3 times 3 is equal to 10. But in calculator math, and which is basically computer math, floating point math, 10 divided by 3 times 3 is not 10, it's 9.9999999, okay? And basically that same kind of problem where because you can't represent an infinite number of digits on a calculator. You can't store an infinite number of digits on your computer either. Weird things happen, okay? And so anyway, with a floating point number, there is a maximum value that we have a thing for representing infinity, but then you also have a largest value that isn't infinity, and it's on the order of like 10 to the 308 power, okay? So it's a really big number, but it's also not the same thing as infinity. We don't run into that problem if we are dealing with integers. So I could take, so here I have the floating point number 2.0, okay? And I could raise it to the 1023, and I get something on the order of 307th power, okay? I can raise 2 to the 1023 plus 2 to the 1022 plus 2 to the 1021, so on and so forth, and I get a pretty big number, something on the order of 308, okay? However, the number 2 raised to the 1024 power, this is beyond the biggest number that can be stored in a calculator, on the computer. It's kind of like, again, think back to an old school calculator. If you have like an 8-digit display, what's the biggest possible number you can represent? It's going to be like 9 8s, right? It'll be like 9999999, which is, what is that? 99,999,900,000. No, 99 million? I don't know. Okay, something, right? Eight digits. The biggest number you can display, I think, is 1 less than 100 million. Okay, because 100 million would take 9 digits. So it's 1 less than 100 million. And so if you say, hey, I want 100 million, this is basically the equivalent on the computer. 2 to the 1024. It says, I can't do that. It's too big. Okay. It says overflow error. This result is too large. Okay. So anyway, that's what we have. Okay. So this is my example. If I do 1 plus 2 divided by 10, so I get 3 divided by 10. And if I do 1/10 plus 2/10, we would think, like in normal math, these two things are the same. Okay. But on the computer, they are not equal. If you do A is equal to 1 plus 2 over 10 and B is equal to 1/10 plus 2/10, these two things are not equal on the computer. And if you say, hey, print out like 20 decimal places, you can see there is a slight difference, okay? So in one case you're getting, 10 divided by 3 times 3, you get, 0.299999999. And then the other case, like if I did 10 times 3 and get 30 divided by 3, I get back 10. I get things that are just ever so slightly different, okay? And that's basically what's happening here, okay? There is a function called math.isClose. So you have to import the math module, and math.isClose, they'll say like, hey, are these two numbers pretty close to each other? And the answer to that is going to be true, right? It says 9.99999, pretty close to 10. Yes. Are they the same? They're not, but okay. All right. With integers, on the other hand, so notice I'm doing 2 and not 2.0. I can raise, Python will store integers of arbitrarily large size. You're limited only by your computer's memory. Okay, so I can do 10 to the 23rd, and it's this really big number. It computes every single place value. Okay, whereas a floating point number, 10 to the 23rd, it only does the first 16 digits. Okay. And remember, with floating point numbers, I was not able to do 2 to the 1024. 2 to the 1024 resulted in an overflow error. This number is too big. Integers, Python says, no problem. Okay, that's a really big number. Calculates all of the things. 2 to the 1025, we can keep going, all right? And the computer will do it. It's just, you will be limited by how much memory, right? If you do a really, really big number, I don't know how many digits. Obviously, if you got 16 gigabytes of RAM, it can probably hold a pretty big number. Okay, not infinity, but a pretty big number. I don't know how big. Okay, and I don't know if we'll ever. Okay. All right. So 9 squared is 81. And again, you might be surprised. There's no square root function in base Python. If I say, hey, what's the square root of 9? It says, I don't know what a square root is. Square root's not a function that's defined. Obviously, Python knows what a square root is, but you have to import the math module. Okay, you have to import math, and you have to call math.squareroot, and that will work. Okay, but you can, like, if you don't want to call math and you want a square root, you can do 9 to the 1/2 power, and we know that's how you can calculate square roots. Okay, pi also doesn't exist on its own. There's no exponentiation function, no trig functions in base Python. Okay, in the base library. Python is what we call a lazy language. Okay, and this is not a derogatory thing. It's a design standpoint. Okay, it's a design choice, which in Python is it is not going to do anything until it's asked to do it, until it's like kind of forced to do it. So, like for example, you can tell you can tell Python, hey, come up with a range of numbers from 1 to 1 billion. Okay, and it's going to say, all right, I got that in mind. But it doesn't actually think of all of these numbers until you say, hey, what is, like, print out all of the numbers, and you say, oh, you want me to print it? Then it will start listing them off. Okay, and same thing, it's the same design philosophy is kind of put in here, where it's just like, I don't want to actually have to know what a trig function is until you like demand it. And then if you're going to demand it, you're going to say, open up your math module. Okay, so anyway, math module, we just call import math, and then we can get any of these things. Math.squareroot, sure, can do that. Math.pi is, pi to 16 decimal places. Math.exp, the exponential function. You have trig functions. What's the sign of pi halves? On your circle. So 1, things like that. Okay. Okay, yeah, we calculate pi. I forget. But yeah, we get about 16 decimal places of precision for pi, and that's good enough for like everything, pretty much. Okay, you'll see these things where it's like, oh, if you know pi up to like 30 decimal places, you can calculate the circumference of the universe within like the radius of 1 atom. I don't know, I'm just making that up, but I think it's something like that. And then, pi up to 16 decimal places, that's what NASA uses. And it's not that like NASA came up with, this is the optimal number for pi. It's just, this is how we represent floating point numbers. And NASA is not going to represent, require a different floating point system. Yeah, this is good enough. Okay. All right. Our true false values, we spell true capital T, lowercase R-U-E, and we spell false capital F, lowercase A-L-S-E. Any other spelling of true doesn't work, and it has to be true with no quotes around it. You put quotes around it, it becomes a string. Okay. You spell true any other way, it's going to say, I don't know what you're talking about. Okay. So it has to be spelled exactly this way. All right. Strings are basically our character thing. Python recognizes either the double quote or the single quote, and that's good. Okay. We have strings are iterables, and so we have functions like length, which will tell you the length of an iterable. So in this case, hello, how are you? It will tell you how many characters are in there. Okay. And then with iterables, you can also use operations like multiplication to kind of duplicate. So in this case, we'll take message 2, multiply it by 4, and it's it's that. And then you can also insert values, okay, into a string. All right. So in this case, I'm creating a variable. My name is Miles, and then here I'm placing a string, and then I use this format operator, okay? And so Curly braces have a kind of a special meaning in strings. And so here this will replace a field, okay, with whatever it is. So here I can just say dot format, plug in something. So it's expecting two kind of fields. And then for the name, I'm going to plug in the variable name, school UCLA here. And that fills out. Okay, I'm going to forget. So hang on. Oh, all right. I have to look up my view quiz answers, so give me a second there. Okay, as far as variables go, you use the equal sign, okay? I don't think that's a surprise. Sorry, I'm getting logged in. Okay, always has to be on the left-hand side. So the variable name is on the left-hand side, okay? That assigns it. You can then retrieve the value later on, okay? From a computer standpoint, okay, this computer science standpoint, Pythons are what we variables in Python are what we call pointers, okay, and so they you have a name that points to a location in memory, okay. So when we say x is equal to 4, Python is going to create a location in memory that has just some kind of address and says, oh, keep in mind the number 4. And then we have, I want to use like our terminology, but basically we have x, okay, the name x, and that name x points to this value 4 in memory, okay? And I can just keep kind of like, I can write a bunch of lines of code here, x equal to 1, and that's going to define the value 1 somewhere in memory, and the name x is going to get pointed to this thing. Now I'm going to create a string in memory called hello, and x is going to point to that. And then I create a list in memory with the values 1, 2, 3, and x is now going to point to that, okay? And so, so that's just what happens. In a different language like C, you know, you create these things, you create these buckets that hold your values, and then later on, if you stop using them, you have to like get rid of them, okay? Python automatically has this thing called the garbage collector, where it will kind of look at and say like, oh, is anything using this object anymore? All right, and if it realizes that like nothing is referencing a certain value or object in memory, then the garbage collector automatically kind of gets rid of it to kind of free up your memory and stuff. Okay, variable names, you can use almost anything you want to be a variable name. These are the keywords that you are not allowed to use as variable names. Okay, so these are the rules. Okay, they can't start with a number. And as far as special characters, the only character, you can either have letters and numbers or an underscore. Okay, no symbols other than an underscore, no spaces, and no keywords. These are all of the keywords. Okay, let me give you, before I forget, I'll give you your first two view quiz answers. First one is B as in bear, and the second one is A as in apple. B as in bear, A as in apple. Okay, this is a little excerpt on the art of naming variables, okay? So the ideal scenario is you name your variables in such a way that when you read your code, you can understand what your code is doing without having to remember in your head what all of the variables names like are, okay? So like when you read the code, hopefully you can remember, oh, this name is referencing like a list or an iterable of names or something. Or this object name is just a numeric value, or this object name is a a Boolean value or something like that. You want to be able to name your things. Now, naming variables in an intelligent way and like this is actually really hard to do. And I don't follow my own advice here in a lot of my lecture notes because I just keep using the variable name X and Y and J and N. And those are terrible names, okay? Using single letter names for a variable is generally not recommended, with the exception of like indexes and loops, right? For I in this range or for J in that range, something like that. As far as like iterable loops, those are like the single variable things. But generally, if you're going to call have something there, you want to have a name that helps us understand, okay? And that's so that you, when you read your own code later, can understand what you were thinking at the time you were writing your code, okay? This is some recommendations on naming variables, but basically, yeah. Be clear and concise, use English, and we have don't contain special characters, and technically you can have like, A with the double dots. I think we call that an umlaut and stuff, but better stick to just like the 26 upper and lowercase letters on your keyboard. Okay. All right. So this isn't great. S or SID, not the best thing. Okay. Also, not a great variable name either. Okay. Like we have tab completion. So this is Finnish Meteorological Institute observation station ID number. Okay. So this will help us remember some of these things. Okay. So perhaps a better way is we can do something like FMI station ID, and we can use snake case or camel case. These are kind of the techniques we use to separate out words. So underscores to separate out words, underscores instead of spaces, we call that snake case. And then if you don't use underscores, but you use kind of capital letters to kind of indicate the first letter of each word, then that's what we call camel case. And these are probably better identifiers here. Okay. And then just some tips is that if the object you are naming is a list or an iterable or something that contains multiple values, consider giving it a plural name so that there's an implication that there's going to be more things. So as far as here's a list containing the strings apple, banana, and orange, okay? The best name for something like this is going to be the variable fruit names, okay? Because that's going to indicate that it is plural, and the fact that it is names tells us that probably the contents of this thing is going to be strings, okay? Whereas if you just have fruit, yes, that does describe the contents of this thing, but are we looking at one or multiple? Okay, and so fruit names would be the best because the inclusion of the names is it implies that the list contains strings. Okay, so that when you're reading your code later and you have like some kind of loop operation for object and fruit names, okay, for fruit name in fruit names, okay, that can help. Okay, if you have a variable with that's going to contain a true false Boolean value, the recommendation is to write the variable name as a yes or no question, okay? So rather than using the variable name selected, do is selected, okay? And rather than the variable write, use can write, okay? Like, can it write? Yes or no. Okay, fruit, you can say has fruit, okay? And that will be like a true false. And, you know, especially when you have something like this, later on, you can have these if statements, right? So if is selected, okay, then, you know, as you're reading this, okay, okay, you know, you can kind of read these things where you don't have to, you don't want to do stuff like this, okay? If is select, if, right? So that, like, this is the same, okay? But this is like more cumbersome, right? Like, if you have to do like if selected, right? So if you're just using these things, if selected equals true, blah, 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 or, okay. Okay. If selected equals true, or, you know, you can just do if is selected, okay? And is selected will be either true or false, and you can kind of just do these things, right? If can write, if has fruit, and it supports the idea of like your code is almost like readable in English, okay? And again, much better, okay, than if X, okay? Because, you know, if you just store your true false value as X, right? All of these are like, syntactically, they are all equivalent. But as far as like being human readable, the one where we name it is selected is going to be much better than if X, okay? If X, or if X equals true, okay? All of these things. This is redundant, okay? X is going to just be true or not. You don't want to do if X equals true. Just do if, no, so anyway. Oops, delete that. Okay, similar kind of thinking as far as variables that use store numbers. Okay, adding a descriptive word can be helpful. So instead of just like rows is equal to 3, you know, what are we talking about? Minimum rows, max rows, total rows, current row, those types of things. These little descriptors suddenly make the variable much more useful. Okay. And then similar kind of naming ideas and naming practices, and this isn't just for Python, but just programming in general, is you know, when you name your functions, you want to give it some kind of action verb, okay? Or, yeah, I mean, give it some kind of verb form, and you might use an action verb or a passive verb, okay? So you can think of like, is it, you know, think of the verb throw versus throw being the active thing, or is thrown would be like the passive form, okay? And yeah, this part, the naming of your variables and functions and stuff like that, requires a little bit of effort and thinking. And but in terms of like making your own code readable, it's worth the effort. Okay, so if you have a function that's going to modify an object, give it an action verb. And then if you have a function that doesn't modify the object itself, but returns a modified version of the object, you might give it the passive verb, okay? And so, so this principle has been applied to Python, and you have the function sort, okay? And you also have the function sorted, okay? So here is a list, okay? So I've got car brand names, and we've got, you know, Ford, BMW, Volvo, Toyota, and we have the function car brand names.sort. And what this does is it will take the object car brand names, and it will sort it. And so car brand names itself has been modified, okay? And if I ask, what is car brand names? If I print car brand names right now, it is in sorted order. It has been sorted because we called the function sort on the thing, and so this object has been modified, okay? Here I'm going to create a new list. New list car brand names here. And over here, I'm going to use the function sorted, okay? And so sorted will give me what is car brand names if I had sorted them, okay? And so it's going to say, okay, in alphabetical order, if you sort them, you'll get Audi, Chevrolet, Honda, okay? This is sorted, okay? But because it's the passive form of the verb, it doesn't actually modify the list. The list is in the original order, okay? This is a subtle difference, okay? But this is the design philosophy behind a lot of the functions in Python, and it's the design philosophy that we would recommend that you follow, in that here, this function is modifying the list so that it actually does, so that the list will forever be changed, okay? So it's saying sort this, and so that is changed, okay? Over here, we're saying, hey, I just want to know what the sorted version looks like, okay? And that's this. And actually, part of the object-oriented system is that sort is a method that belongs to the object, okay? And so that's why we're calling it car brand names.sort. And over here, sorted is just a kind of a function that exists for any kind of iterable thing. So there's no method dot sorted, okay? This if you try that, you'll get an error. This list doesn't have an attribute called sorted or a method called sorted, and then the function sort doesn't exist in kind of the global space. Sort is not defined. You only have sorted, and then the method dot sort. Okay. All right. So this is just kind of a brief introduction to just some of the kind of basic things there. Let me give you your third view quiz answer. Last view quiz answer for today is the letter C. C as in cat. C as in cat. Okay, and I think that's it. Have a great weekend. We'll see you on Monday.